Alright, so a very common identity that you might use when factoring is called the difference of two squares. And so as a little intro to that, take some time and distribute these out and see what you get. So this one is x times x, which is x squared. We get negative 3x and positive 3x. And 3 times negative 3 is negative 9. So when I simplify that, did you notice what happened here? Since I had the same number, but one was positive and one was negative, what happens is these are going to cancel each other out, leaving just x squared minus 9. All right, let's try the next one. 5m squared times 5m squared is 25m to the 4th. 5m squared times 1 is 5m squared. 5m squared times negative 1 is negative 5m squared. And negative 1 times 1 is negative 1. Notice the same thing happened here. Since these were the same, just one plus and one minus, the middle two terms end up canceling each other out because they're the same, just one's plus and one's minus. So we just get 25m to the 4th minus 1. So without even distributing this, what do you think this is going to give us? If I have two factors that are the same except for one's plus and one's minus, what would that be? Well, if I were to follow this pattern here, notice that the first thing ends up being squared, the second number ends up being squared, and I end up with a subtraction sign in the middle because one was positive and one was negative, which always multiplies to give me a negative sign. So this is most likely going to be a squared and b squared, whatever a and b are, with a minus in the middle. And so this is what we call the difference of two squares. So I was kind of going backwards. What we're going to do is now go the other way. If I have something that looks like this and I want to factor it, the factors always look like the square root of that first term goes in the front, the square root of the second term goes in the back, and then you have one plus and one minus. It doesn't matter which one you make plus or minus because they're the same. Note that this only happens if you have subtraction. That's why we call it the difference, because subtraction, of two squares. So like two perfect squares, things we could square root evenly. A and B could be anything, so we'll go through some examples here. So notice, this is the difference of two perfect squares, something I could square root evenly. The square root of x squared is just x, and the square root of 9 is 3. So the factors here, there's going to be two of them. These factors are going to be pretty much the same. They're both going to have an x in the front. They're both going to have a 3 in the back. But all you do is make one of them plus and the other minus. And that's it. Those are your two factors of this expression. Again, you could always check your work with factoring. If I do x times x, I get x squared. If I do negative 3x and positive 3x, those cancel out, and then 3 times negative 3 is negative 9. So this does work. Let's try another one. Again, you need to check and make sure you can actually use this method. So is this the difference of two squares? Yes, it is. So I'm going to square root x to the 4th, and that's x squared. And I'm going to square root 16, that's 4. And so I'll fill those into my factors. The x squared goes in the front of both of them. The 4 goes in the back. And again, make one plus, make one minus, and there we go. So this one actually keeps going. Notice that this factor is the difference of two squares. So this one actually keeps factoring. It's almost like if you broke down like the number 30 into its factors, you could break it into like 3 times 10, but 10 keeps breaking down into 2 times 5. Same thing is happening here. I broke this expression down into 2 factors, but this factor keeps breaking down, so we need to keep factoring. What's the square root of x squared? That is just x. And what's the square root of 4? That's a 2. Then again, make one plus and one minus. All right, this first one, we could almost factor it, but not quite, because it's not a subtraction sign right here. So we're not going to be able to factor this first one. We'll just leave it as it is, x squared plus 4. So all 3 of these multiply together to give me that original expression. These are all factors. All right. It might be tempting to say, yes, I can factor this. It would just be like x plus 2 and x minus 2. But if you make 1 plus and 1 minus, you always end up getting a negative 4. So x plus 2 and x minus 2 are not going to give me this. So maybe you're thinking, well, what if I made them both positive? Maybe that'll work, because 2 times 2 does give me 4. The problem with this is that then I'll get 2x and 2x, which is 4x. The middle terms won't cancel anymore. So it's not possible with real numbers to do that. And we'll talk in the next video about how it is possible, but not yet. All right, let's try this one. Again, this is the difference of 2 perfect squares, things like its square root evenly. The square root of 9x squared is, square root of 9 is 3. The square root of x squared is x, so 3x. The square root of 25y squared is a 5, and the square root of y squared is y. Be careful when you're doing this, when you're square rooting, the negative doesn't get included. You're just square rooting what's on the end. It has to be a minus, because when you have a positive and a negative and you multiply them together, that's what gives you the minus. So don't kind of ignore the negative until the end. So here's my 2 factors. I'll fill in 3x at the beginning, 5y at the end, and make 1 plus, make 1 minus. Doesn't matter which. I can't keep going on that one, so we're done. All right, on number 4, you notice that it's the difference, but it's not 2 perfect squares. I can't square root 3. So is this even factorable? Don't forget, the first thing you want to do anytime you factor, no matter how many terms it has, is factor out a GCF first. This one does have a GCF of 3. So if I bring that 3 to the front and divide this by a 3, I get just x squared. And divide this by a 3, I get minus 1. So now that that 3 is kind of out of the way, you'll notice that this is now the difference of 2 squares. So I'm going to fill in my 2 factors. The square root of x squared is x. The square root of 1, square root of 1 is just 1, because 1 times 1 gives you 1. So fill in a 1 and make 1 plus, make 1 minus. Don't forget also to leave the 3 in the very front, not in the parentheses, but on the very front of your expression. Just a few more examples. This is the difference of 2 squares, because the square root of x to the fourth, like what times itself gives you x to the fourth, that would be x squared, or 4 divided by 2 gives you 2. Same thing for the y to the fourth, square root of it would be y squared. So my two factors are going to be x squared and y squared. And again, make one plus, make one minus. Be on the lookout, because sometimes they do keep going. This is another one that keeps factoring. The plus is stuck, but the minus, we could keep going with this one, keep breaking it down. So, I'm going to split this into two factors. The square root of x squared is x. The square root of y squared is y. Make one plus, make the other minus. And leave this in the front as well. So all three of those are my factors for this expression. It's kind of crazy. If you multiply all this together, you end up just getting two terms, but that happens sometimes. All right, the rest of these are going to go pretty fast. Number 6 is a difference, but it's not the difference of two squares. I could square root x squared, but I can't square root 2. And there's not a GCF. So this one is not factorable. We would call this prime, meaning it can't be factored. Just like a number that can't be factored is called prime. You could technically do this if you really wanted to. If you square root x squared, you get x, and if you square root 2, you get the square root of 2. So if you really wanted to factor this one, you could say x, and square root of 2, and square root of 2, and make one plus and one minus. I'm okay if you just call this prime because we don't really care about irrational numbers here, but if you really wanted to factor it, you could do this. Same issue on number 7. It is a minus sign, so that's good, it's the difference. We could square root this, but we can't square root 7. So again, you could factor it using radicals, but I'm just going to call this prime. It does not factor. And finally, this one, it's tempting to be like, oh, that would be x plus 10, x minus 10, because we want to be 100. But if you have a plus and a minus, that's going to give you negative 10, and this is, or negative 100, and this is supposed to be positive 100. So it's not possible with real numbers, with real factors, to do the sum of two squares. We'll talk in the next video about how you could factor those, but for now, I would just call that prime.